Good day. I'm Joseph Noor. I'm a medical doctor and a biochemist, and I'm the author of Document X, Direct Evidence of God's Existence. I want to discuss now the life cycle of stars according to the Quran. Now, where do stars come from? Were they born sometime in the past? Will they die one day? Why do they shine? These are questions that should be asked by any person because it raises our awareness of the mystery and beauty of the universe, increases our consciousness of something much larger than ourselves, which lies at the heart of creation. So what are stars? Stars are glowing spheres of hydrogen and helium gas. They are nuclear machines. They produce radiation. They are also chemical factories. They make the atoms that you and I are made of. So how do stars form? Stars are formed when a cloud of hydrogen and helium gas, billions of kilometers across, collapses under its own gravity. And as the cloud collapses, it releases gravitational energy which heats up the interior of the cloud. And as the temperature rises, it agitates the hydrogen and helium particles and enhances their collision rates. And with continuous compression, the temperature rises until it's so hot that the electrons are stripped from the nuclei, and these charged particles now flow freely in the kind of a hot plasma. Now, once a critical temperature is reached inside the cloud, about 10 million degrees, the star turns on. Now, why does this happen? This is a result of the initiation of thermonuclear reactions. This is how it happens. When hydrogen nuclei within the cloud come together, they tend to repel each other because they are positively charged. And as I said earlier, charged particles, they repel each other. But when they come close enough so that a strong force becomes operative, they fuse. A hydrogen nucleus consists of one proton. And when two hydrogen nuclei fuse, they produce helium, which consists of two protons. The process is actually a little bit more complicated. But in essence, 4 bits of hydrogen are converted each time to 1 bit of helium. Now, 1 bit of helium has less mass than 4 bits of hydrogen. And this mass discrepancy is released as energy, some of which is poured out into space, like the sun emitting radiation, which warms and sustains our planet. And the rest of the radiation is used to uphold the star. Now, the heat produced by thermonuclear reactions exerts a gas pressure, an outward gas pressure, which tends to uphold the star. But this gas pressure is opposed by inwardly directed gravitational forces produced by the star material. So the stability of the star is therefore maintained by these two forces opposing each other. Gravity trying to crush the star and gas pressure trying to explode the star. So stars therefore exist in a state of tension, and during this time interval they steadily shine. Now the sun, like all other stars, have limited supplies of fuel like hydrogen, and about 4 billion years from now the hydrogen stores of our sun will be depleted and our sun will suffer an energy crisis. What will happen now is gravitational force will start to dominate, and this compresses the core, which releases a spurt of energy which causes the outer layers of the sun to swell up, and the star will increase its size by 100 to 200 times, producing what we call a bloated red giant. And over time, because of overwhelming gravitational forces, the sun will continue to shrink, losing large amounts of material to the surrounding interstellar medium until it reaches the size of our Earth. And such a star is called a white dwarf. Further shrinkage is blocked by electron forces. Imagine our sun, in which initially 1 million Earths could fit, will now be the size of the Earth only. Now let's look at the destiny of stars. Now our sun is an average sized star. So the Quran describes the destiny of the sun. But this will also apply to the destiny of other mediocre stars. In chapter 75 verse 9, the Quran states, when the sun and the moon are united into a single mass. Now there are 2 interpretations to this verse. One, an orbital disruption of the sun or the moon resulting in a collision, maybe due to a passing star. And the second interpretation is a reference to the red giant phase. Our sun will swell up 100 to 200 times its size incinerating and engulfing nearby planets, including the Moon. Now this is supported by the following two verses, in other words, the red giant phase. Chapter 55:37 states, when the sky becomes red, inclining towards yellow and other colors, it's conceivable that the changes in the sky are meant to reflect what is happening inside the sun, because the distended sun will fill a large part of the sky, forming a kind of a red burning halo around the earth. And if there are any descendants around, they will witness a blazing red sky. Now, the red sky can also be explained in the following way. We know that the atmosphere appears blue. This is the result of particles in the atmosphere which deflect the sun rays, causing the sky to appear blue. Now, with a red giant phase, the atmosphere will be displaced, and there will be no particles to deflect the sun rays, and the sky will therefore appear red. The red giant phase is also supported by the following verse, chapter 81, verse 6, which states, when the oceans boil over. So the massively swollen sun will boil the oceans, and the oceans will gush away into space. What is the meaning of the color change as stated earlier in 55:37? When the sky becomes red, turning towards yellow and other colors. Now, the end of a star's life is marked by a series of dramatic changes in temperature and density. And these can be detected as variations in the pattern of light colors emitted by the sun. And this phenomenon, where temperature changes cause a change in the color spectrum of a star, was only discovered 150 years ago. So note the correct sequence described in the Quran. It speaks about the sky becoming red, then yellow, and then inclining towards other colors. Now, it is plausible that the changes in the sky are meant to reflect the variations happening in the sun, because the sun will fill a large part of the sky. Now, visible light, as we know, consists of several component colors arranged from the lowest equivalent temperature to the highest temperature, starting with red first, then follows orange, then yellow, green, and blue. We know that stars that have a blue color have a higher temperature than stars that have a red color. So, when the star enters the red giant phase, the temperature starts to increase, it will predominantly radiate in the red part of the electromagnetic spectrum. And as the temperature continues to rise, it will then radiate predominantly in the yellow part of the region. And as the temperature continues to rise, it will emit radiation in the rest of the colors of the EM spectrum. In the meantime, the sun will continue to shrink because of overwhelming gravitational forces, until eventually it reaches the size of our Earth, and further shrinkage is blocked by electron forces. Now, this shrinking process is referred to in chapter 81, verse 1, which says, when the sun becomes folded up and loses its brilliance. Now, when you fold up something, you squeeze it into a smaller size and it becomes compact and denser. Now, the same will happen to our sun. When it decreases in size, it becomes more compact and denser, and then eventually end up as a white dwarf. The second part of the verse speaks about the loss of brilliance of the sun. And this means that the contraction of the sun will happen towards the end of its life cycle, when its energy and light reserves run dry. Not all stars end their lives as white dwarfs. After going through the red giant phase, what happens next to the star depends on the initial mass of the star. Stars that have a mass about 6 to 8 times the size of the sun, they have immense gravitational forces. Their shrinkage is not blocked by electron forces. What happens is that these stars can drive nuclear reactions until the iron stage, so that at the end of their lives, their core consists of iron. With no heat to resist the collapse, the compressive force transforms the iron into a sea of neutrons. And this happens when the stellar fragment is the size of the Earth and weighs about 1.5 solar masses. The star then collapses until it forms a neutron star, which is the size about 10 kilometers across. Further shrinkage is blocked by nuclear forces, and the result is a stable neutron star. Supermassive stars have an even more dramatic fate. They don't end their lives as neutron stars. What happens is this: with the sudden loss of the interior, the outer layers of the star is left with no support. And these outer layers, weighing trillions and trillions of tons, come down crushing, smashing into the newly formed neutron star. And this violent encounter creates a cosmic force of unimaginable size, literally blowing the star apart. And for a few seconds, the star outshines a billion suns. Is it just a spectacular display of fireworks? Or is there a reason for it? These stars, they produce the elements like all other stars during their lifetime. And in their death throes, they create the heavy elements such as silver, gold, and aluminium. So when they explode, they hurl these life-essential chemicals into the surrounding medium. And this unimaginable force, as a result of the blowing up of the star, creates a pressure wave, which moves through space at 10% the speed of light. And as it sweeps through space, it carries with it these life-essential chemicals, compressing gas and dust in its path, and may even trigger a collapse of gas and dust, giving rise to stars, planetary systems, and supernovae. Our solar system was perhaps triggered by a collapse of dust and gas caused by a supernova. It's a sobering thought that stars explode millions of years ago can influence events halfway across the Milky Way galaxy, creating the atoms that you and I are made of. Now, how do we observe supernovae? These explosions are called supernovae. We observe them as bright objects in the sky. On the 23rd of February 1987, astronomers observed a bright object in a large Magellanic Cloud, which is a satellite galaxy situated about 170 million light years away from our galaxy. Now, this star had appeared exactly where there was a massive star. Now, astronomers map the sky just like geographers map the Earth. They record the locations of particular stars. And this bright object appeared where this massive star was. And this massive star was present the night before as determined by telescopic observations. Somehow it has disappeared. And this sequence of events is consistent with the supernovae. The blowing up of the star explains the disappearing act of the massive star, and the bright object, the explosion. Now obviously this explosion didn't happen in 1987. It happened 170 million years ago, because it took light 170 million years from the large Magellanic Cloud to cross the intervening distance and reach our galaxy. Now, bearing the following facts in mind: number one, that the nature of supernova was only discovered in the 1930s by a Bulgarian scientist. And secondly, stars at the time of the revelation of the Quran were considered to be feeble lights in the sky. The Quran has this to say about the supernova in chapter 86, verse 1, 2, 3, and 4. Consider heavenly space and the night visitant therein, which appears suddenly after a cataclysm. And what would make thee conceive how great the night visitant is? It is a star of piercing brightness. Now, this is a fitting description of a supernova. Firstly, it is described as a night visitant because it is brightest in the night time. But more significant is the term visitant, which also means newcomer. Like a guest, the star appears suddenly and unexpectedly in the night sky and then fades and disappears. It's not a permanent resident in the sky, but like a guest leaves after a brief visit, relatively speaking in terms of astronomical standards. This is no ordinary star the Quran is describing, and hence the rhetorical question: and what could make thee conceive how great the night visitant is? It is a star of piercing brightness. Now, the Arabic word at-tariq conveys to us the sudden and violent nature of this event. As I said, for a few seconds, this explosion outshines a billion suns put together. The explosion and implosion of this cataclysmic event only lasts for a few seconds. My insertion in 86 verse 1, 2, and 3 is based on another verse in 53:49, and this verse states, "It is He alone that sustains a star, which appears when heat and energy is generated in its core, giving it its bright appearance. And this is another reference to a supernovae. So such a star appears or becomes visible as a bright object as a result of a surge in energy production. Now supergiant stars, which is about 25 times the size of our Sun, have an even more bizarre fate. The neutron star phase is not blocked by nuclear forces because these stars have incomprehensible gravitational forces. So the nuclear forces are no match for these intense gravitational forces. Now what happens is that when the star collapses and forms a neutron star and you have the supernova explosion, the immense gravitational forces of these stars squeezes the neutron star into a smaller, more compact object. And as it squeezes into a smaller object, the gravitational force becomes greater and the star contracts even more. And this is a process that is unstoppable, feeding on itself and continues until the star catastrophically implodes into a super dense state. The gravitational field of this super dense state so massive that not even light can escape from it, and hence the term black hole. How do scientists observe black holes when they do not emit light? Assuming there's a distant galaxy out there, and there's a black hole between us and that galaxy. Now light from that distant galaxy on its way to us will be distorted by the black hole, and this process is called gravitational lensing. Scientists can pick up these distortions and infer the presence of an intervening black hole. Black hole can also be studied by observation of the velocity of stars. Now, black holes may be referred to in the following verse, in chapter 15, verse 16, which says, "And certainly we have set up unseen structures in space derived from large stars, which manifest themselves to their great gravitational forces, and which are gateways." So, since these stars betray their existence in the indirect way and not visually, I've inserted the word unseen. And they are derived from large stars. They are detected because of their massive gravitational forces influencing neighboring cosmic structures. They are also described as gateways. Why? We found that the passage of time is affected by the intensity of gravitational fields. Now, a black hole has immense gravitational forces. It affects the flow of time. Now, if you step into a black hole and remain there for 2 or 3 seconds, and you step outside the black hole, you'll come back in a far, far distant future. In other words, inside the black hole, time slows down tremendously, and at the singularity, which is the center point of the black hole, time actually comes to a standstill. So this has led to the exciting suggestion that black holes may act as time machines, called wormholes. It's a kind of a entry or exit or intergalactic tunnel leading to other space-time dimensions. The idea of black holes has also been expanded in 2130 discussed previously, where it is described as a closed-up entity exerting a massive gravitational force and imprisoning light. Now, what are the functions of black holes? It is believed that at the center of large galaxies there are supermassive black holes. And these black holes play an important part in shaping the structure of the universe. They also emit intense bursts of radiation called gamma ray bursts. And these highly energetic rays, they move across the sky for light years, clamping down on the clumping effect of gravity, and reduces the number of star formation. So it produces a quieter galaxy, allowing planets like the Earth to exist and preventing it from being fried by nearby supernovas.